Hi guys, and welcome to another look at some of the features in KherveFitting, the new open source and free software for analyzing XPS data. It's Mark from XPS. Today we're going to be taking a look at some backgrounds, how we can start to model our XPS data using KherveFitting, what kind of different backgrounds we can use, and kind of how we find all of this in the software. So let's get going. So I've just loaded up nickel oxide standard. It's got a couple of different regions and different orbitals that we can look at that maybe require us to think about our backgrounds in a slightly different way. So let's start with the carbon region. Okay, so I'm assuming you're familiar with kind of how to open and move around KherveFitting, but this little drop down up here is just going to allow us to reach our carbon 1s orbital. So now we're going to start to think about how we can put in some backgrounds, which is a really important part of fitting your data. You can't really start to do any peak modeling until you've got a kind of background that describes the data and the inelastic scattering process as well. So we've got our carbon open. There's a couple of options up here for getting started with backgrounds. There's a full option in create peaks model, which is opened with Control P or with this little icon up here. And next to it, there's a simplified version, which is the same icon, but it's just called Mini. So we're going to start with that one because there's not so many options to look through, and it's just quite a useful way to go through and just really quickly create backgrounds so you can get going. Right, there are only two options here. So we open this mini peak fitting window, and there are two methods. We've got a smart or a U22 guide, and if you haven't come across smart backgrounds before, they are something that you might find in Avantage, the Thermo Fisher Scientific software. They essentially apply a Shirley type background, but they can account for certain things like rising backgrounds due to loss features and stuff. So they're usually pretty good at automated processes because they can kind of filter out some of the things that you might not necessarily need to worry about if you're manually sorting your backgrounds, but when automated processes come in, small differences in the spectra need to be accounted for. So that's what the smart background is. For the purposes of this video, we're basically just going to treat it like a Shirley background because we want to control exactly what we're modeling anyway. So once you've got this window open, we can just click either side of our peaks to add kind of limits of where we want to stick the upper and lower limit of this background, and then we can just click on create region, and that will give us a simple Shirley type background here that we can use as our base to start our modeling. You can see here, if we click and drag, we can control a bit where this background goes. So if you have somewhat noisy data and you're sitting on a bit of a peak, you can move this across and just get that background going through the noise really nice and smoothly. You always want your background to kind of be going through pretty much the middle of the noise, as it should be like an average representation of that, and give yourself a couple of EV either side of the peak just to make sure you've got enough room to account for peak tails and get your models looking really nice and fine. So that's the really quick simplified version. So now let's take a look at the more intricate version with a lot more options. Okay, so we've moved over to our nickel 2p region. A lovely nickel 2p, as anyone who's done XPS modeling and first row transition metal will know. We've got all these really complex peak shapes due to multiplet splitting. So we're going to open up the main background fitting window, which can be found here. Again, you can open Control P to open this up. So the peak fitting window, the first tab that opens is the background. And now you can see we've got quite a few more options. So we can select here, as well as the smart, we've got specific Shirley or linear type backgrounds. Linear is probably not something you would often use. It's good for polymers if you're looking at carbon and oxygen, but in reality the Shirley background basically does exactly the same thing, so you might as well just use the Shirley, or in this case the smart, as again that's more or less doing the same function as the Shirley as well. There's the U22 guard background as well, which we'll go into a bit more detail in a bit, as well as the U4 background, which is the 4-component 2-guard. There's also a Raman background, which we're not going to touch on in this session, but if you want to start fitting Raman data in KherveFitting, and then Gwilym has introduced some really nice features for that, and the Raman background can be used to analyze Raman peaks. So we're going to do the same thing as before. We're just going to click either side of our peak, and then we can start fitting our background. So I'm going to specify a Shirley background. Now, so the Smart will do the same thing, but we'll specify a Shirley just so we can create a region here. Now, what you'll probably see straight away is that our background doesn't look great. It's going through the data. So in the middle, in between our spin orbit doublet peaks, so in between the we've got the nickel 2p3/2 here, and the kind of satellites and multiplet structure here, and then we've got a nickel 2p1/2 here, and just here in the middle our background's going through the data, which isn't physically possible. We can't have a background that goes above the data, so this is quite a bad background that's come in by default. So we need to find some way of modifying this. So we can try and change our limits, but that's not really having any effect. Maybe if we'd extended our scan range out a bit more, we could possibly apply that further down, but as it stands, we can't do that. So there's a couple of things that we can do. You'll notice we've got more options in these boxes now. So here we've got some options for offsets. So what we can do is essentially extend how the background's calculated without actually extending the regions of these backgrounds by applying an offset. So the offset on the left hand side will fit the Shirley background as if it's trying to fit a point further on in the data. If you want to know a bit more about how the maths of Shirley backgrounds influences the kind of the background that you get, I'll stick a link to our Guru page on backgrounds, which goes through how this Shirley model is kind of calculated and how it works. But suffice to say, if we stick in an offset, that's going to change how this background's calculated. So I'm just going to stick a 5 EV offset in. Maybe we'll go for a bit more, maybe 50. So you can start to see that this is coming down a bit now. By the looks of it, we need to go quite a bit higher. There we go. So we've moved further and further down into our spectra, and this background is now kind of compensating for this difference in where the start and end points are fit. Now you can see that our background is going through the data quite nicely. It's not rising above the data at any point, but kind of how realistic this background is up for debate. I mean, it's not going to be, certainly not going to be a realistic model of the inelastic scatter of the electrons. That's not what the Shirley background does, but we also don't meet the end of our spectra here to our background, which, if you're careful in your fitting, probably isn't the biggest problem, but I'd probably still try and avoid it if we can anyway. You're probably going to come up with issues in terms of reliability and repeatability with a background like this. But nevertheless, this is one option that can be used. This is a particularly useful option if you've got data that's been recorded and you have something like an overlapping peak, and further down you've got a bit of a rising spectra that you can't account for in other ways. So you can stick in an offset and move your background down so that it kind of ignores any peak overlaps, which we'll try and find an example of in a bit. But nevertheless, this isn't a great way of compensating for the background rising above your spectra here. Okay, so another approach we might want to take is to just split these regions into two. So instead of having a single region, we can put a start and end point so that it meets in the middle, where we have this kind of dip that we're going through with our background, and then we can start a new region. So let's use this opportunity to also highlight these boxes here. So region left and right. You can just type in exactly where you want the region to cross. So we're crossing it to about 867.5 roughly. So let's change this one to 867.5, hit enter, and then yeah, pretty much bang on. We've got our region going through there. So we can now add a second region exactly the same way. We can just do create a region, and then we can toggle here between the two, and this time we're going to start at 2886, let's say, and then the right hand side is going to go to 865.7, and we can just toggle this a little bit. 867. Here we go. And now they're meeting at around 867. They're being forced through that dip point where before our background was kind of going through the data, and now we've got a really nice and smooth Shirley type background that's going through the data and is meeting the spectra at either side. So that looks really good. If you accidentally add, too many regions and you want to get rid of one, you can select the region that you want with these little tabs here, and then just remove current region, and you can see now we're back to our 2. You can also remove all of the regions if you want to completely start from scratch. If you've already added peaks, which will be going on in a future video, you can kind of remove everything and start from scratch here as well. But now we've got a really nice looking Shirley type here. Let's have a look at some of the other backgrounds in there. Okay, so I'm just going to remove all of these regions that we've added so far. We'll get back to this point where we're just looking to add a new region, a new background. So I'm going to come down to the U2 two-guard first. So this is a universal type two-guard background with only a 2-component parameter adjustment. So you can adjust parameters B and C. If you want to know a little bit more about how the two-guard background works, I will link again our guru page on two-guard backgrounds here. But the U2 is nice and simple. You can use it in the same way that you would use a Shirley or a linear or smart. And here you can see we've stuck in our two-guard, and we could do the same kind of modifications as before. And just adjust our start and end points. We can also use this function here, the averaging points, to increase the number of data points that we use to find the kind of average Y value through the noise of the data. So the bigger this number is, the more of an average you're taking through your data. But of course, that means that you have a wider region to get this average from, so you need a really nice and flat background either side of the peak. If we increase this too much, say something ridiculous like 30 or maybe even 60, you can see that then this region that's being taken here, the start and end points can be seen here, are going to be going well into our peak, so we should be getting a pretty ridiculous background. We'd have to restart to get it to actually fit through that. But clearly we could only do this if we've got a really nice and flat background either side of the peak. You don't need that many points anyway. 5 is usually pretty good to get an idea of the statistical noise. But again, if you've got really noisy data, maybe you want to bump that to 7 or 9 just to be sure. So that's the U2 two-guard. You can adjust these parameters here. So let's say, for example, take B down to 3000. Again, if you want a reminder about what these refer to, check out the guru page below. We'll just create a new region here, and what you should be able to see if we remove all regions, create a new region with our new component parameters, we've got a slightly different point at which we're starting to see this loss onset occur. As always with the two-guard background, you kind of need to know a little bit more about your sample, need to know a little bit more about the inelastic scattering of the photoelectrons in this material. The This version of the U2 two-guard that Gwilym's introduced here, you can be a bit more flexible with, so it can get you a reasonably good background to work with to start modeling, particularly asymmetric peaks. But again, you kind of want these parameters to be as close as possible to realistic. So you can find for a lot of materials, common materials like silica, you can find these parameters either online or in XPS. So Neil has a couple of kind of standard backgrounds that will automatically populate these cross sections for you. But again, you should be able to find some of them online as well. If it was an unknown material, then of course you need to do a bit more work into finding out what these are, or you just use a Shirley type background. It depends on your needs. Again, the two-guard backgrounds can be a bit advanced. So certainly if you're just starting out doing XPS analysis, I would stick with the Shirley or the smart backgrounds. Absolutely, for sure. So now we can have a look at the U4 two-guard, which has got a little bit more going on with it, thanks to some of the things that Gwilym's introduced here. Okay, so I've switched to a different sample. It's just some nickel metal, just because I wanted a bit more of a flat background to work with for this example. If we switch to the U4, what you'll see now is this option here, the two-guard Raman, opens up. So this does a little bit of modeling to help populate some of these two-guard parameters for you, some of the cross-section parameters for you. So if we open this window, you'll be given a few options. Now, the first one is where the background is going to start. So of course we want to start, around 849 is fine. This is below the peaks. And then we want to define the range that the two-guard background is going to try and fit to. So this takes the background post-peak and models some of the ways in which it presents itself in order to back-populate some of the two-guard parameters in the cross-sections. So you can see at the moment, the range it's trying to take includes this 2p1/2 peak. So we can just move this to a flatter background area, about 880. That should move that line here. We're back up to 870. No, wrong one. 885 to 880 minimum, and then that should hopefully look more sensible. Yes, so we're now trying to fit that actual post-peak background. If we click fit, it should generate us a two-guard background which tries to fit that kind of tailing slope at the end to the data. We don't have a huge post-peak background here, so it can only do a reasonable job. Really, if you want to be looking at these types of backgrounds, you want to be opening up a very large background data set. I'll open one in a second just to show you, but quickly here, once we've kind of got these parameters, you can copy them to the peak fitting screen, and you'll now see that these two-guard parameters over here have been populated. And so we can close this, create a region, and that will pop in the two-guard background that we've just shown. So that's it on a quick guide to using the backgrounds in KherveFitting. As I say, we'll come with a more detailed video on how to really get to grips with that U4 two-guard background in the future. With some good examples with extended backgrounds, but for now that should be enough to get you started on using KherveFitting and getting those backgrounds in to start your peak modeling. Next up, we are going to be looking at peak models, how to put in some kind of simple curve fits into our data. So look out for that in the next few days, and I'll see you soon. Thanks for watching. Goodbye.